As you can see, this example is from the 2013 Advanced HSC exam. There will definitely be questions like this in the exam. It's very hard to find one from the HSC that only covers the concept of differentiation. As you know, we can integrate as well. And we haven't looked at that yet, but it doesn't mean I think that you couldn't understand why you might integrate or what integrating would give us. So I'm going to stick with doing, this example just to see if you can maybe work through it, which actually gives you a good understanding of exercise 3C. So it says, the velocity of a particle moving along the x-axis is given by the velocity. So that's important to read that. Note that x has got a dot on it, and it does use the word here, and it's in terms of time. And when it just says it's going along the x-axis, that's just back to this idea, you know, that I said you can always think about your particle moving just backwards and forwards along a horizontal axis. So our particle is moving along the x-axis according to this, where x is the displacement. Well, that's what we understand because x dot is the derivative, is the notation for derivative of x, and the derivative, the rate of change of displacement with respect to time, is called velocity. So we expect that x would have been displacement. T is time. Initially, the particle is 5 meters to the right. Now, clearly that's important. Initially, the particle is 5 meters to the right. How do we note that? What does that mean? It means that initially is always t is equal to 0. Initially, t equals 0. Make sure you make some note of that. So when t is 0, the particle is 5 meters. What's our official name for where a particle is? Hopefully you know the answer to that is displacement, x. So when t is 0, x is 5 meters to the right is a plus 5. If it had said 5 meters to the left, we would need to give it, although it'll say 5 meters, we'd need to give it a displacement value of -5 if it said to the left. 1. Show that the acceleration of the particle is constant. What does that mean? It shouldn't have any t's in it. It's just a number. So how do we get acceleration? Acceleration, there's a few things we know. It is dv dt, and I think that is what we would use in this case. I'm going, instead of using the notation x dot, I'm going to write v is 10 minus 2t. Now, acceleration being dv dt, differentiate my v with respect to t, all I've got is a -2. Like I said, the calculus is generally on these not going to be too difficult. They're not testing whether you can differentiate, they're testing do you know what differentiating a displacement or a velocity function actually gives. So, which is a constant. -2 is a constant. What does that mean? It's got a constant negative acceleration. And acceleration is a force. So think of it, we know that velocity is, in our lay terms, the speed at which it's going. What is this concept of acceleration? Acceleration is a force that's being applied. It's having a constant negative force. What do you think the impact of a constant negative force on something would be? A constant negative force means it's going to stop it going in the positive direction. It's going to make it go in the negative direction. And not that it's asking for that, but it's just some understanding of what's going on. Part 2, find the time when the particle is at rest. A particle is at rest. When? What do you know? A particle would stop moving. 0 speed. It's at rest. 0 speed. What's our mathematical term now for speed? Is velocity. 0 velocity. A particle is at rest when v is 0. So actually, no calculus involved in part 2. This is really straight out understanding question. The particle is at rest when v is 0. What was our equation for v? V is equal to 10 minus 2 naught. Therefore, we've got to solve 0 is 10 minus 2 naught. When did the particle stop? When 2t was equal to 10, after 5 seconds the particle stopped. Or is at rest. Is at rest? Again, you can interpret to mean it has stopped. Part 3 says show the position of the particle after 7 seconds is 26 metres to the right of the origin. Okay, now this is where we move into the concept of integration, because, and you can stop the video here because we haven't talked about integrating. You can stop the video here and just do the questions from exercise 3b if you like. I don't mind. If you want to keep on with it because you're thinking, well, we've got an expression for velocity. If I integrate velocity, I'm going back to where it came from. What did velocity come from? Velocity came from an expression about displacement. What does displacement tell us? Displacement tells us about the position of the particle. So show the position is like find x, displacement, after 7 seconds, that's time, and we've got to show that it's actually 26. Find that x is actually 26, a positive 26. So we've got to find that x, or actually show that it's 26, when t is 7. So we had they started with velocity. What do we know? We know that we could get back by integrating velocity with respect to time. Now, like I said, and again, you can stop this at any time because we haven't been through the integrating process. So that's what we do. To get displacement, we're going to integrate. What is our velocity? It's 10 minus 2t, obviously with respect to t. So x would be equal to 10t, integrating with respect to t, minus t squared, plus a constant. We need to work out this integration constant. Now, that's why we were actually given this important information here. It said that, and you'll get used to this and know to go looking for it in the future, that when t was 0, x was at 5. So x was at 5 when t was 0. So we've got that the constant is equal to 5. That gives us, therefore, our complete function for displacement, which is 10t minus t squared plus 5. Then what did we want to do? We wanted to investigate what x would be when t was equal to 7. X will be equal to 10 times 7 is 70, minus 49 plus 5. 70 minus 49, I think, would be 21. 21 plus 5 is 26.